In this video, I'm going to review how to draw Bohr models for atoms and ions, which you learned last year. So we'll use oxygen as our example. We're going to draw one for the oxygen atom, and then we'll draw one for the ion that forms. And you'll remember that with ions, the ending of the nonmetal changes to "ide." So if it was, say, nitrogen atom, as an ion, you'd call it nitride. For metals, when metals change into ions, the name doesn't change. So if it was an iron atom, you just call it an iron ion. Okay, so the Bohr model, what you want to look at is your periodic table to find oxygen, and you'll see it has a mass number of 16 on average, and an atomic number of 8. The 8 represents the number of protons. It's got 8 protons. And the 16 is the total number of protons and neutrons. So if it has 8 protons and it has to add up to 16, it must also have 8 neutrons. So there's different ways to draw Bohr models, but usually we write the protons and neutrons in the middle. And then we write the electrons around the outside. And for an atom, the number of protons is going to be equal to the number of electrons. The atoms are electrically neutral, so all the positive charges have to equal the negative charges. And the way we draw it is we put 2 electrons in the first energy level, or shell. Now this model is a little bit misleading. The electrons don't orbit the nucleus the way planets would orbit the sun. It's not perfectly spheres like this. They actually occupy regions of space called probability clouds, which we don't get into in grade 10. But the point is that they do exist at specific energy levels and not in between those levels. So a good analogy for where the electrons are, it's like a staircase. And each stair represents a different energy level. The electrons can exist at a particular energy level, but they can't exist between them. And so this model, at least it illustrates that. So this shows that these 2 electrons are on the same energy level, the lowest energy level, closest to the nucleus. After we've put in those 2, the next energy level can hold 8. And the way we usually fill them in is 1, 2, 3, 4, and we need 2 more to draw, so there's 6 total, so that it adds up to 8. The reason I drew them like this is it's easier to count, and later on, if you take Chemistry 11, it's a little bit easier to discuss bonding if you put the electrons in pairs like this. But you also see Bohr models drawn where the electrons are all spread out evenly. So I would have 6 electrons in this outer shell, all evenly spaced. And that's also a good way to draw it, because that would show that the electrons are as far apart from each other as possible, which makes sense. They're all negatively charged, and therefore they would repel each other. Okay, I'm going to do the ion in a separate video.